All right, slide into the free response part. I'm going to show you what I would put down on the free response answer sheet. Okay. Show you how like less is more. Just get the right answers. Do some work on the side. Put your answers over there. So let's just like practice doing that for this. So hopefully you can read everything. We got this function. We got some points, -1, 0, 3, 2. I'm sure we're going to use that. We got g is 2 plus 3 log x. We're trying to find h of 3, which is g of f of 3. H of 3 is g of f of 3. This is f. F of 3 is 2. G of 2. We want a decimal answer will be 2 plus 3 log 2. Okay, so I'm going to just start copying that down. I know that I'm good with this work, and I am going to put h of 3 equals g of f of 3. I'm going to put h of 3 equals g of 2. I'm going to put h of 3 equals 2 plus 3 log 2. And that's approximately 2 plus 3 natural log 2. If it's a log of a different base, you can find log base in math A, or you can use the change of bases, which is like log number divided by log base. So we get 4.079, and we will leave that 3 decimal places, rounded or truncated. Find all zeros of f or indicate there are no real zeros. Okay, so the zeros are when f equals 0. So f of x equals 0. F of x equals 0 at x equals -1. Done. Find all values x as decimal approximations with g of x equaling e. Okay, so g of x equaling e would be 2 plus 3 log x equals e. I'm going to have e minus 2. Yeah, so 3 log x equals e minus 2. Log x equals e minus 2 divided by 3. So I have that work. G of x equals e. 2 plus 3 log x equals e. You don't have to do this. You could have just graphed and found the answer. It's a little silly. I forget that you can use your calculator. Honestly, I feel like this is silly.
You came to watch your kids in action?
I'm sorry. I wish I could show.
Yeah.
I'm recording a video now. You guys can be on my video.
Oh, no, we don't need your video. That's okay.
1.270, 1.271. And you could check by doing the math algebraically. E minus 2 divided by 3. E to the power of that number. 1.272. But you don't have to do that. Determine the end behavior as G increases at bound. So like you can see it on your graphing calculator if you wanted to, as the x values increase, the y values increase. So we need to use limit notation. I'm going to just go straight to the answer. As x increases without bound, put the x approaches infinity under the LIM, put g of x, and put infinity. There's not a number. It's a log function that increases exponentially slowly, but it still increases. Determine if f is invertible. So the answer is going to be yes or no, and the answer to this is yes. And we talked about this in question 1. we wanted the definition of each output has a unique input value. That's kind of what they wanted. Or if there's a counterexample, you say the output 3 does not have a unique input value. It's got two inputs that produce that output, which means if you flip it, then you'd have that input producing two outputs, which you can't do. So the reason is like you will say each input or each output is produced by a unique input. Each y value comes from just one x. Okay. Question number 2. Oh, this is a tough one where A and B are in different spots. Thanks, Passwater. Love you, bud. This is the rumor question. So we have 2 points. It's probably good to put the points down here. After 2 hours, there's 15 students. After 6 hours, there's 67. This is not as bad as the other piecewise where one of them's a number, and you have to know that the number has to equal the bottom piece where it starts. 667. So my 2 equations are going to be 15 equals 7 times a to the 2 over 2. They want it simplified, so that better be 1. And my other equation is negative 213.29. 67. I'm plugging in 6 into the bottom piece. 67 equals negative 213.29 plus b log 6. And find a and b, algebraically very simple. And that's what I'm going to do, is find a and b algebraically simply. Probably going to, I could show my work here. 15 over 7 is a. And then they want them as decimal approximations, so you better give them a decimal approximation. 2.142 or 143. And then b equals, and you could show this work, it's not going to hurt if you want to, if you know exactly what you're doing. Or you could go straight to the answer. Yeah, I like that question because you don't use stat edit. All right, 100%. Use the given data to find the average rate of change. Show the computations that lead to your answer. So this is the slope, the y's over your x's, but it's not y's over x's here. It is amount of students that have heard the rumor at a certain hour, per hour. So it will show us on average how many more, how quickly the students who have heard the rumor is increasing. The amount of students that heard the rumor is increasing or decreasing by this value. So show the work if you want to just quickly get the answer without doing any more work. There it is, and you get 13. And do they ask you for units? No, just show the computations. Interpret the meaning. Here's the meaning. The meaning is, I'm recording. Over the hours t equals 2 to t equals 6. Debbie already popped by. And now I'm eating. Over the hours 2 to 6. The number of students that have heard the rumor is increasing by 13 students per hour on average. Okay, write neater than I do. Consider the values that result from using the average rate of change. Okay, this is when we're thinking about an average rate of change is linear. It's a slope of a line. If I continue to use the average rate of change, I'm going to go off of the points that I have on the line. Too many students are just using the average rate of change from 0. But make sure you know, like, we have a point on the line, we have a point on the line. On average, we're going up 13 Ys per X students per hour. Are the estimates from this line less than or greater than the number of students predicted by the model? Between 0 and 6. Okay, great. It's not after 6 because that's tricky. That's good. That's good. So what we'll find is I'm starting at 6. Oh, no, we're actually using this piece from 2 to 6. So you have this exponential function that's kind of passing through these points like this. So you can see the points on the line are greater than the points on the curve. Explain your justification using characteristics. So the answer is overestimates. The average rate of change is constant. The rates of change of your model are increasing. I feel like that's sufficient. The average rate of change between two to 6 is constant. It's 13. Average rates of change, the rates of change in the model are increasing because we're concave up. I don't know what else they're looking for. Model C is valid from 0 to 12. Explain how the range values of the function R should be limited by the context of the problem. Well, let's see. If B is 156.432, if I go from negative 213, if I go negative 213.29 plus 156.432 natural log of 12, I get 175. That's a reasonable number. Like, if the model is from 0 to 12, the students heard is a maximum of 175. I don't know if you want to put like R of t. And then if I put 0, I get 7. So it's like I'm also starting at 0. If I plug in 0, I have 7 times a to the 0. Which is 7. So if the model, the range of R of t is limited to between 7 and 175.430 students. You could like state that out. The range of R of t is limited to between 7 and 175.430 students. If you're not comfortable using this, using inequality notation, you can say the range is limited to between. You can literally say the words between 7 and 175. I'm wondering if they care about. I don't think they'd care about the decimal or not. 0.430 students. And that's going to get you 12 points or 11 out of 12 points. Don't drop points here. Less is more. Don't forget about outputs produced by unique inputs for invertibility. All right, cool. We're done with the first half. Sorry for my penmanship, but you know how it is with me. Peace.